Assalamualaikum and hi, my name is Nelly Novianti binti Sabudi. So today I would like to explain about lab 6 of control principle, which is system stability. Okay, as for part A, it is root locus and plot board magnitude. Okay, so the coding for root locus and plot board magnitude already given. The first one is the for root locus and the second one is for plot board magnitude, and the transfer function is given here, so you just need to use this transfer function and write your coding. Okay, as for root locus, it is a technique used in the field of control system which can determine the stability of the system. It also can be used to determine the damping ratio and natural frequency of a feedback system. As for board plot, it is a graph of the transfer function of a linear time invariant system versus frequency plotted with a log frequency axis to show the system's frequency response. So, as for the plot board magnitude, there are two elements can be seen at the graph later, which is magnitude and phase. So this is my coding. I write my coding based on the question. Actually, you can write your coding separately for root locus and plot board magnitude. But as for me, I write my coding. I combine my coding and using figure 1 and figure 2 so that my graph will appear at the same time. Okay, so I already run my coding. So as for the output, it will get the same as the transfer function given. You can check whether the transfer function you insert here is correct or not by looking at the output. Compare your output here with the given transfer function at the question. Okay, so this is my graph for figure 1 and figure 2. Figure 1 is for root locus and figure 2 is for plot board magnitude, as you can see here. Okay, so as for part B, root Horowitz and root locus. Okay, root Horowitz is a method that you can use to determine the stability of the transfer function using calculation like this. You have to use this method when the denominator of the transfer function is more than 2, which means you can calculate the transfer function with calculator. So you have to use table like this. As you can see here, as for the first question, okay, this is the transfer function that you are going to calculate on first, second and third. Okay, as for the first question here, as you can see here, I already calculate. Okay, so as for the first transfer function, and it is unstable due to change of polarity. As you can see here, there is -2 here, which means the polarity change. So there is a negative polarity here, but all of the rest of the polarity is positive, only one is negative, so we can conclude it is unstable. As for the second one, it also unstable due to the change of the polarity, but as for this one, there is value 0 here. When you calculate, there is 0 value here, so you need to replace the 0 value with value smaller than 0. So I assume the 0 here as 10 power of -8, so you need to calculate it, and you get negative here also. That means the system is unstable. And as for the third one, okay, as you can see here, the third one is, sorry, okay, this is the third one. Okay, the third one will produce 0 at column S3. As you can see here, this is S3. At column S3, all of it is 0. So this is a special case where you need to use this kind of method. You need to differentiate the S3 row. Okay, so this is the new value that are going to replace the 0 at S3. As you can see here, I replace the 0 at S3 with 8 and 24, which is the value here that I already differentiate. So since the polarity is same, all of the polarity positive, so we can conclude that the question number 3, the transfer function for number 3 is stable. Okay, so as for the coding, you can use this one. This coding, you just need to copy and paste this coding here. And as you can see here, I already combined my coding and with all of the transfer function. So I put the coding here so that my graph will appear at the same time. And I already use figure 1, figure 2, figure 3. I already explained earlier. So I using figure 1, figure 2 and figure 3 also in this part so that my graph will appear at the same time. Okay, so you just need to run section. If you want to use the coding separately, you can also use the coding separately lah. Okay, this is the graph for figure 1. This is for figure 2, which is there are poles at right side and left side. That's mean and it is unstable. And this is for figure 3, which is we conclude that as a stable system. Okay, so that's all from me. Thank you.